Welcome to the Air Pollution Distance Learning Network. I'm Allison Davis from EPA's Office of Air Quality Planning and Standards. Not since we took lead out of gasoline in the 1980s have most Americans thought about lead in the air, but it's still here. And in October, EPA took an important step toward protecting public health from that lead. I'm joined today by Lydia Wegman, Director of the Health and Environmental Impacts Division at the Office of Air Quality Planning and Standards. Lydia is going to give us a brief overview of EPA's action.
Thank you all for joining us here today. I'm delighted to have the opportunity to introduce you to our new ambient air quality standards for lead. The standards were issued on October 15th. The standards are the first tightening of the standards that were originally issued in 1978. So this is our first revision in 30 years to the ambient air quality standard for lead. The new standards dramatically tighten the public health protection offered by our ambient air quality standards for lead. The original standard issued in 1978 was set at 1.5 micrograms per cubic meter, and the new standard is 0.15 micrograms per cubic meter of lead in the air. That is a tenfold tightening of the standard and will provide increased public health protection for the entire American population, but especially for children living near sources of lead. Lead has many health effects associated with it, including IQ loss, the risk of delinquent behavior as children move from childhood into adolescence, learning disabilities, and poor academic achievement. In addition, adults can experience health effects from exposure to lead, including increased blood pressure and cardiovascular disease. I should also note that lead has effects on the environment, and our new standards will protect not only public health, but the environment as well. Today, we have the good fortune of being joined by three experts in the three areas covered by our new standards. The first area addresses the standard itself, and that will address the level of the standard as well as the indicator, averaging time, and form. We also have new monitoring requirements that go into place with our new standard because we need additional monitors to address the areas which have not previously been monitored. And we have an expert to talk to you about that. And lastly, we have someone to talk to you about implementation and how we will be moving forward to implement this new standard in a rapid fashion. So thank you again for joining us. You will have an opportunity to send in questions, and we will provide answers during the course of this broadcast.
You can submit questions during the broadcast, or you can wait until our 5-minute break, which we will take after we hear from our experts. There are 3 ways to get your questions in: by email, or by fax, or by telephone. That information is on your screen. Joining us now is Deidre Murphy, a toxicologist who led the development of the new lead standards. Deidre, let's start out with how the new standards compare to the old ones. What's the difference?
Well, the most significant difference is with regard to level. The level for the old standards set in 1978 was 1.5 micrograms per meter cubed. The level for the new standards is an order of magnitude lower at 0.15 micrograms per meter cubed. We also made some changes with regard to the 3-month averaging time and to the way it's calculated. And lastly, under the new standards, we've allowed for the use of data on lead in particles smaller than 10 microns, lead in PM10, under some limited circumstances.
Well, let's back up a step and talk about just lead in the air in general. Haven't emissions been reduced since lead was removed from gasoline?
The phase-out of lead from gasoline resulted in a dramatic reduction of emissions of lead to the air and associated reductions of the concentration of lead in the air. However, our estimates today indicate that there are still some 1,300 tons of lead emitted to the air per year from some 16,000 sources. I should also note, however, that over the last 30 years since the standard was set, we've now learned a lot about the health effects associated with lead that indicate that there are effects of lead associated with levels much lower than what we knew when the standard was set.
So what kinds of lead's out of gasoline? So what kind of sources are out there now that are contributing this lead to the air?
The largest source of lead nationally, of lead to the air, is associated with the use of leaded gasoline in small piston-driven aircraft. These are not the scheduled commercial flights, but these are smaller general aviation gasoline. And then on an individual basis, large sources of lead include those associated with metals industries, such as smelters, foundries, and also mining activities, and also some manufacturing sectors such as cement and glass. In looking at our monitoring data, the highest levels of lead in the air are associated with the air near smelters.
So we know there are, I think you said 1,300 tons of lead emitted to the air each year. How are people actually exposed to that? Do they breathe it in?
People are exposed to lead from the air both by inhalation of the air but also by ingestion. Ingestion is a major route of exposure to this lead, and that's because lead is emitted to the air in the form of particles of different sizes which travel different distances based on the size, but which eventually settle out of the air onto surfaces, including hard surfaces as well as soil and water bodies, and people contact those surfaces and incidentally ingest the lead. And this is a very important pathway of exposure, particularly for young children whose behavior includes a hand-to-mouth activity whereby they contact the lead on the surface and then ingest the lead through that contact.
So how does this lead exposure affect people's health?
Lead exposure is associated with a broad range of health effects. It's associated with effects on the nervous system, effects on the cardiovascular system, effects on kidney, on the immune system, and also on the function of red blood cells. The effects of most concern to us today are the effects on the nervous system of children and the effect on the cardiovascular system of adults. The nervous system effects include neurocognitive effects and neurobehavioral effects, which can impact children into adulthood. And these include effects on IQ, on academic achievement, as well as on behavior.
So the new standards, as you mentioned, are an order of magnitude 10 times stronger than the standards that were set in 1978. What led the agency to issue this much more protective standard?
Well, first, the evidence with regard to the effects associated with lead exposure is much expanded since the standards were set in 30 years ago in 1978. Today we have evidence of effects, serious health effects associated with lead exposures at much lower levels than we knew when the standard was set. And this evidence includes multiple epidemiological studies that have found associations between the levels of lead in children's blood and effects on IQ and on neurological function. And these associations have continued to be found as epidemiological studies have studied children with lower and lower blood lead levels. Additionally, this relationship between IQ loss and blood lead level is stronger or greater on an incremental basis. That means the IQ effect is greater per microgram per meter cubed of blood lead when a child has lower blood lead levels than when they have higher blood lead levels.
Let's shift now to the actual review of the standards themselves. The process for reviewing the lead standard was a little different than the process that we have been used to, that was recently used for a particulate matter a couple of years ago, for example. Can you tell us a little bit about the process that was used for reviewing the lead standards?
During the course of the lead review, the agency revised the process for how we reviewed the National Ambient Air Quality Standards so that the lead review contained aspects of both the old process and the new process. The review began in 2005 on a very tight court-ordered schedule, and the review of the science, which is documented in the criteria document, was completed at the end of September in 2006. Then the exposure risk assessment and a staff paper was released on November 1, 2007, and then we came into the new process. And as part of the new process, we released an advance notice of proposed rulemaking a month later, on December 5, 2007. That was followed by a comment period, and then the proposed rulemaking was released on May 1 of 2008. We then had 2 public hearings, and the final rulemaking was signed on October 15 of 2008.
All in all, for a National Ambient Air Quality Standard, a rather compressed schedule.
It was quite a compressed schedule. And an additional aspect which is important to the NAAQS review and which occurred in the lead NAAQS review is the role of the Clean Air Scientific Advisory Committee.
And the schedule you just mentioned, part of that review process is getting advice from the Clean Air Scientific Advisory Committee, or CASAC. What did CASAC advise in this review, and was the agency's decision consistent with that advice?
Yes, the agency's decision on the lead NAAQS was consistent with CASAC's advice in nearly all aspects. CASAC concluded that the old standard of 1.5 micrograms per meter cubed did not provide requisite protection of public health. CASAC also, in considering IQ loss as the sensitive effect in this review, concluded that an IQ loss of 1 to 2 points was highly significant from a public health perspective. And based on that conclusion, they recommended that the agency revise the standard to a level no greater than 0.2 micrograms per meter cubed. And if the agency were to retain the indicator of lead in total suspended particles, they suggested that level should be no greater than 0.1 micrograms per meter cubed. Additionally, they recommended a revision to the averaging time to a monthly averaging time. However, they recommended also that if we retained the quarterly or 3-month averaging time, that we revise to a rolling 3-month averaging time from the current block calendar quarter. And then lastly, they recommended a revision to the secondary standard, recommending that it be revised to a level no greater than the level of a revised primary standard.
And we're going to go through these now in a little bit more detail. Let's talk about the standards themselves first, the level. The agency selected 0.15 micrograms per cubic meter. What led you to this particular level?
First, in considering the full body of evidence that's available now, the agency concluded that the old standard was not providing the requisite protection of public health. The revised level was selected in consideration of the currently available evidence and provides increased protection for children, which are the sensitive subpopulation for this review, and it particularly provides increased protection for children living near sources where the levels of lead are highest. The revised level was selected in consideration of the evidence within a framework focused on IQ loss in children as the critical effect. This framework allowed us to integrate information on the relationship between lead in air and lead in children's blood, and on the relationship between lead in children's blood and IQ loss.
The level isn't the only part of the standard that helps protect public health. Averaging time and form are part of that also. Tell us now about the averaging time and form for this new, more protective standard.
Sure. The new standard is in terms of maximum rolling 3-month average. The old standard was in terms of maximum calendar quarter average. So the main difference, one of the main differences, is that under the old standard, only 4 averages each year were compared to the standard. The average for January to March, April to June, July to October, and July to September, and October to December. Under the new standard, there are 12 3-month periods which will be compared to the standard. So each 3-month period within a year is given equal weight in this new standard. Additionally, we've changed how we calculate the average over the 3-month period so that in the calculation, we calculate first the average for each month in the period, and then the 3 monthly averages are averaged to create the 3-month average.
Let's talk now about lead in PM10. You mentioned a few minutes ago that the agency is going to allow states to measure lead in PM10 under certain circumstances. What are those circumstances?
As I said, we retain the same indicator. The standard is in terms of lead in total suspended particles. But under certain circumstances, we're allowing the use of lead in PM10 data. And those circumstances are in areas where we do not have sources of lead in larger particles, and where the monitoring agency can demonstrate that the concentrations of lead in the air are not expected to be greater than 0.1 micrograms per meter cubed.
We've covered the level of the primary standard, we've covered the form and the averaging time. Before we go, let's talk now about the secondary standard. What did the agency decide to do there?
The decision on the secondary standard was to set it identical to the primary standard. This was based on a review of the evidence with regard to welfare effects, which indicated that the old standard was not providing the requisite protection of welfare. However, the evidence did not provide the specificity that was needed to independently set a separate standard, secondary standard.
Thank you, Deirdre, and thank you for joining us today. Deirdre is going to stay with us, and she'll be available to answer your questions after the break. The email address and telephone number for submitting questions are on the screen.